Compound inequalities, and we pick up a couple new symbols here. We have ands and ors, and those are going to stand for union and intersection. So I'll explain those kind of as I go. The symbol for or is going to be this, which is union. X is less than or equal to 3, or union x is greater than 7. So these are just exactly what they would look like. We just come over the graph and graph each of these intervals separately. So we're going to have 3 here going that way, and we're going to have 7 there going that way. And so what this or says is it's this stuff over here or that stuff over there. So it's just the way that we paste together an answer that has like 2 separate intervals. So in interval notation, and again, if you haven't watched the interval notation video and you're having troubles with interval notation, check that out. So this is going to go from negative infinity up to 3. And that'll be a bracket because we have this solid dot. And the way that we get over the gap is this union symbol. So union on the computer, that's just a capital U. And I think there's also a click thing in the pull down menu. Come up to 7. And then from there we go to infinity. So that's an or. An and is an intersection. So an intersection, make an upside down U as a symbol. And then we graph these two things. And I'm going to graph them separately for a second, and then I'll show the actual answer together. So I would have x is less than 5, so I'm going to just come up here above the graph and go, that's going this way. And we have x is greater than 1, so that's going this way. And what the intersection is where both graphs are. So it's this area right here where they overlap. So then let me come down here to the graph and draw the actual answer. So on the computer, don't draw both graphs. This is saying that little region right there where both graphs exist, that's our intersection. So that's our solution. And in interval notation, that would be from 1 to 5. And parentheses because of the open dots and the no equals. So then this is another way to write an and. This is saying 2x minus 3 has to stay between the 7s, between negative 7 and positive 7. And we'll see that in some upcoming sections. To solve this, if you think about how you would solve it if this wasn't here, you just add the 3 and divide the 2, right? So you do that exact same thing. You're just going to do it in 3 places instead of 2 places. So then this becomes negative 4 less than or equal to 2x, and then less than 10. And then next we divide the 2, right? So we still just do that. We just do it everywhere. So then this ends up negative 2 less than or equal to x less than 5. So coming up to our graph, we're going to have negative 2, and then 5 is our other endpoint. And what this is saying is that the x is staying between those 2 values. So we have something like that. So we go from negative 2 and then up to 5. And then parentheses to match the no equals. So this one's a union, but it's kind of how to show you how to deal with fractions again on the computer. So I'll just solve each of these independently and then deal with the answers together over here. So I'm going to add 1. Go ahead and write that at the same time. So here we're going to have 3x, these cancel, that's going to be less than negative 3. Here they cancel, we got the 3x, that's going to be greater than 5. And we can divide our 3 over, and we get x is less than negative 1, or x is greater than 5/3. So x is less than negative 1, that's cool, that's right here. X is greater than 5/3, so remember 5/3 is the same thing, 3 goes into 5 once with 2 left over, so it's 1 2/3, so you can come up here to 1. It's already going to be cut into thirds for you, so just count over 1, 2, and then that's your other endpoint. And then an interval notation, that's going to look like negative infinity up to negative 1. And everything's parentheses because there's no equals. Union. Don't do the mixed numeral, do the improper fraction. 5/3, this is just for graphing. And then up to infinity. Okay, and then these next three in the lecture section, I would have you try. So we got an or here, so I'm going to do -9, -9. Just solve this one out. Less than or equal to -3. We can divide over the 3. So for this side, we get x is less than or equal to -1. And then I'll do this one, -7, -7. So that's going to be 2x is greater than or equal to 4. And then divide over the 2. And x is greater than or equal to 2. So to our graph, we'd have -1, we'd have 2, solid dots with equals, x less than, and then x greater than. And interval, we'd have -infinity up to 1, union 2 to infinity. Number 6 is a continued inequality, so I'm going to do the thing where I just, again, think about what you would do without this other piece. You'd add the 6 and divide the 2. Do the exact same steps. So I add the 6 and I get -2 less than or equal to 2x less than, let's see, that'd be 10. And then divide out the 2 everywhere. It gets us -1 less than or equal to x less than 5. So -1 will be solid, 5 is going to be open, and then the x has to stay between those. So that would be just like this. And -1 up to 5, parentheses. And then this last one here, so it's got a fraction in there, which isn't that big a deal. I'm still going to, if I had this, I would still subtract the 1 first. So I'm just going to do that. And here this is a little weird, but we get 1 minus 1, so it's just 0. That can happen. Less than 1/3 x, which is less than 1. And then I'll go ahead and clear this fraction. I would multiply by 3, right? So I'm just going to multiply everything by 3. 3 times 0 is still 0, so nothing happened there. Cancel those, and I got my x. And on this side, I would have 3. So my solution set is from 0 to 3, and then parentheses 0, comma 3 for the interval notation. And that concludes compound inequalities.